Hello, my name's Thanom. I'm from UNSW. Today I'm going to work through some MATH1011 calculus problems from the section of differentiation. So the first one I want to work through is this one on the average rate of change for this function f of t is t cubed plus t from t equals a to a plus h. But before we do that, I just want to do a specific case from t equals 1 to 2, just to talk about the average rate of change when we've got some numbers. So if I, for example, wanted the average rate of change from t equals 1 to 2, I'm really asking for the gradient of this chord that joins these two points on the curve at t equals 1 and t equals 2. If I want the gradient of that chord, I need to calculate this rise divided by the run. That's how we calculate gradient. The change in y divided by the change in x. The change in x is easy, that's just 2 minus 1. If I want the change in y, I need these y values here. So this top y value is f of 2, right? The function value at 2. When I put 2 in, I get 2 cubed plus 2, that's just 10. The function value at 1 is 1 cubed plus 1, so that's just 2 there. So my function from t equals 1 to t equals 2, it changes from 2 to 10, okay? So we can calculate what this average rate of change is. So the average rate of change, if you like, is the gradient, or the rise divided by the run. That's the change in y, so f of 2 minus f of 1, divided by the change in x, that's 2 minus 1. And f of 2 is 10 and f of 1 is 2, which we calculated before. So the change in y is really 10 minus 2 divided by the change in x, which is 2 minus 1. So overall, we have an average rate of change of 8 from t equals 1 to t equals 2. Now if I want to do it more generally, I want to go from t equals a to t equals a plus h. So let's say we had a somewhere here, and we want to be h away over at a plus h. So the average rate of change is the gradient of this chord here. If we want the gradient of that chord there, then we need the change in the y value divided by the change in the x value there. So this is the rise and this is the run. So how much has the y value changed? Well, this is f of a plus h here, and this one is f of a. So the change in the y value, the rise, is f of a plus h minus f of a, and the run here is just a plus h minus a, but we can see that that's h as well. So now, let's calculate the average rate of change from t equals a to t equals a plus h. So this is the more general case. Again, it's still the rise over run, if we want to think about it that way, or the change in the y values. So that's f of a plus h minus f of a divided by the change in the x values. Well, that's just a plus h minus a, but that's just h. We made that h on purpose. So that's f of a plus h minus f of a. Now, we need to calculate this using this function here, t cubed plus t. So f of a plus h is really a plus h cubed plus a plus h. Okay, so f of t is t cubed plus t, so f of a plus h is a plus h cubed plus a plus h. Minus, well, f of a is a cubed plus an a there, all divided by h. So we need to simplify this expression. So a plus h cubed, we can expand using Pascal's triangle, a cubed plus 3a squared h plus 3ah squared plus h cubed, and then we have to plus another a plus h and subtract an a cubed and subtract an a, and all of this is getting divided by h. And now some things should simplify. Here I have a cubed minus an a cubed, and here I have a plus a and a minus a. So these add to 0 there. So I'm left with an 3a squared h plus a 3ah squared plus an h cubed plus an h. All of these have an h, so I can divide that h out, and I'll be left with 3a squared plus just a 3ah if I divide one of the h's, and h cubed divided by h is just going to be left with an h squared, and this h divided by h will just be left with 1. So here, my average rate of change from a to a plus h is this expression 3a squared plus 3ah plus h squared plus 1. So that answers the question. I just want to write a note at the bottom here. So note that as h tends to 0, this average rate of change, well, as h tends to 0, 3ah and h squared both tend to 0, so this average rate of change tends to 3a squared plus a 1. And that's what we know as the instantaneous rate of change, which is what we expect because we know from our differentiation rules that f dash of t is 3t squared plus 1. And so the average rate of change at a should be 3a squared plus 1. So as h tends to 0, the average rate tends to this. So the instantaneous rate of change at t equals a is 3a squared plus 1, which is what we expect.